Hello. In this C# video, I will be covering properties, one of the most essential features for building clean and secure classes in C#. Properties allow us to control access to the fields inside a class, helping us enforce rules like read-only or write-only access while keeping our code readable and organized. By the end of this video, you will understand how to define properties, use get and set accessors, apply automatic properties, and see how properties support the important concept of encapsulation in object-oriented programming. First, let's start with an explanation. What are properties? Let's start by understanding what a property is. In C#, a property acts like a combination of a field and a method. It allows controlled access to private fields by defining get and set accessors. This lets other parts of your program retrieve or modify values, but only in the way you allow. This is a part of encapsulation, which means hiding the internal details of a class and exposing only what is necessary. Let us start in Visual Studio Code here with a code example about manual properties. So let me show you an example of a basic class that uses properties. So for this, we're going to use a person, but first we need to define using system, and then we're going to define our class person, and then first we're going to define our private field. So private string, and then we're going to do name for right now. So name, and I'm doing lowercase, and you'll see why that's important in a second. So here we are defining our private field. Our next thing we need to do in this class is actually define the property. So we're going to do that by public string name. Note name is capital here. So name is our property. But we need to actually have stuff inside the property. That is going to be our get and set. So get, curly braces, return name. And then in addition, set name equals value. So essentially what this is doing is the get is returning the name of the person, and then the set is changing the name of the person to whatever the value is. So now let's actually figure out how to use this class. But again, the name field is private, which means code outside the class cannot access it directly. The capital name property provides controlled access to that private field. The get accessor returns the current value of name, and the set accessor assigns a new value to name. Now let us use this class. We're going to do that by defining a class called program, and then we're going to do static void main. So the first thing we're going to do is actually define our person. So we're going to do that by person, capital person. Again, with Visual Studio Code here, you can see the yellow underline, and again, if you hover over it, says class person. I'm going to call it lowercase person equals new person. So this person object is an instance of the person class. So we are defining a new person here. The next thing we need to do is we're going to call the set accessor. So we're going to do that by doing person dot name equals, let's say, Bob. So here we are calling the set accessor. Next, let us call the get accessor. We're going to do that by printing out the name of the person into the console. So we're going to do console dot write line, and then we're going to pass in person dot name. Again, here we are calling the get accessor. So now that we have this basic example done, let's open up our terminal and take a look at the output. Let's navigate to the properties folder, and then let's do .NET run. It's going to take a second to load. And as we can see, it gives a warning, and we'll address that later, but it prints out Bob. So that seemed to work out great. Now let us move on to automatic properties. Writing out the full property with a private field works, but in many cases, C# lets you simplify this using automatic properties. So let us edit our person class to all the way down to just one line. So public string name, capital name, and then inside the curly braces are get and are set. With automatic properties, C# automatically creates the hidden field for you behind the scenes. This keeps your code short and clean, especially when you don't need custom logic in your get or set accessors. So let's open up the terminal again. We're going to do, it's saved, so now let's do .NET run yet again. So it's going to take a second to load here. We're getting the same error, which we'll address later, but again, it prints out Bob as our output. Alrighty, so next we want to talk about read-only and write-only properties. You can also control access more strictly. So for example, a read-only property we're going to take a look at here. So let us reset our person class, and then we're going to do public string name, but we're just going to pass get. We're not going to pass in set. But we're also going to come up with a constructor. So again, a constructor is something that you have to define immediately upon creation. So here, public person, and then we're going to pass in a string. We'll call it name, and then in that constructor, we're going to set name to name. Again, capital name to the name that we enter in. Our application is going to be a little different now. So we need to do person equals new person, but we need to pass in a name. So let's pass in Bob. And then we can print out in the same way as we did last time. Console.write line person.name. Let us test that out. It's saved. So .NET run. It prints out Bob, and we don't get an error this time. So again, in this example, name can only be assigned inside the constructor. It cannot be changed later. Write-only properties are rare, but possible by defining only the set accessor. Next, let us add logic to properties. So you can add custom logic inside the get or set blocks. So for example, we're going to move on to age. So let us first declare a private age, private int age. and then we want to declare our we, we want to declare our property. So public int age. So get is going to be returning the age, but we also want to declare a set. So obviously you cannot set someone's age to be negative value, so let us take that into account. So if the value that is entered is greater than or equal to 0, we are going to set the age to equal whatever value. Otherwise, we're going to let the user know that age cannot be negative. So let's take a look back down here, and we're going to first try to declare our person's age to be negative. So we would try to do that by person dot age is equal to, let's say, -1, and then let us print out person dot age. We're all saved. So .net run. It's going to take a second to load. So it says Bob, age cannot be negative, and then defaults to 0. Let us try actually entering in a valid age. So we're going to save .net run. So there's no error message, and it just prints out Bob and his age. So adding logic to properties protects your class from invalid data, which is the key benefit of using properties. Before we conclude this video, though, let's go through a summary and some takeaways. To recap, properties in C# control access to fields, which supports encapsulation. You can use get and set accessors to define how data is retrieved or modified. You can write properties manually with private fields or simplified with automatic properties. And properties allow you to add custom logic to enforce rules. Properties keep your code safe, organized, and readable, which are all essential for building reliable applications in C#. If you found this tutorial helpful, do not forget to like, subscribe, turn on notifications, and leave a comment. Reach out if you have any questions. Otherwise, thank you for watching, and have a great day.